Hello, ladies and gentlemen of my 8th grade physical science. Mr. Escox is back. We are starting Chapter 6 today. Chapter 6 is all about how to make compounds. That is when you take two or more elements and chemically combine them. That would be one of your vocabulary words. We're going to talk about characteristics of compounds. Compounds are very different than the actual elements that they make up, and you have a little bit of reading and some questions later. What do you think of when you hear the word compound? A lot of people think of reactions. When you watch some of the videos in this lesson, there are reaction videos, although they are YouTube that I don't own, but we do use them in class. And we talk about compounds that are elements combined in some sort of chemical reaction. That chemical reaction can cause an ionic bond or a covalent bond, or in some cases they have these ones called metallic bonds. But there's some sort of metallic or some type of bond that causes them to be together. And they have different characteristics than the original elements. A compound is a substance that is made of two or more elements. They must be chemically bonded together. The properties of that compound do not only depend on the number of atoms, but how those atoms are arranged and what type of atoms they are. So we can predict how they will bond and arrange themselves based on their valence electrons. Now, in the last chapter, we talked about valence electrons as being the outer shell electrons. Those are the ones that are going to be involved in this. So here's one here. This is ammonia. Now, ammonia is what you would find in Windex. It's that smelly stuff. It has nitrogen. Now, nitrogen has 5 valence electrons, so it wants to gain 3. So it shares an electron with this hydrogen, shares an electron with that hydrogen, shares an electron. So now, most of the time, nitrogen has 8. The hydrogens would like 2, so they share these 2, and they are now happy. So if we talk about a couple really common compounds, nothing more common than hydrogen and oxygen, right? Water. The oxygen is in the middle, and it shares a bond with hydrogen like this. There's technically 2 electrons there. And it shares another bond over here with this hydrogen. So what happens, it's as if oxygen now has, it starts out with 6 valence electrons. When it shares the 2, one there, and it shares an electron over here, these become our covalent bonds and they put it together. The other one that's real common, CO2, yeah, that's carbon dioxide. Carbon is in the middle. Carbon actually has 4 valence electrons. Oxygen has 6 valence electrons and would like to gain 2. So what happens, this one and this one here, pretend those aren't there. The oxygen is here and it has 6, 1, 2, 5, and 6. There's another oxygen over here, 1, 2, 3, 4, 5, 6. You get a double bond in this case. That electron shares, that electron shares, that electron shares, and that electron shares. Sometimes you'll see it written this way. So how do you represent a compound? You write a chemical formula. On the last page, I showed you a couple chemical formulas. H2O, CO2. Those are chemical formulas. The subscripts are very important because they tell you which atoms or how many of each atoms are there. So oftentimes when we're doing chemistry, we look at atomic ratios. The ratio indicates the number of atoms of each one. So these are completely different substances, even though they look very similar. This is nitrous. That one has a ratio of 1 to 1. This one has a ratio of 1 to 2. This one has a ratio of 2 to 1. Not the same thing. You know, water, 2 to 1. This one, hydrogen peroxide, is actually a ratio of 1 to 1. All right, so let's do some practice here with some ratios. So these are some sample ones. There's only 3. First things first, right? Separate out your 2 elements. So in this case, it's aluminum and chlorine. There's no subscript here, so that tells you that that's number 1. There's only 1. There's a subscript of 3, so there's 3. So your ratio there is 1 to 3. This is mercury phosphate. So we have mercury, we have oxygen and oxygen, phosphate and oxygen. The mercury is only 1. The P, which is phosphorus, is 1. There's only 1 oxygen, 1 to 1 to 1. And then last but not least, ammonium sulfide. When you see a subscript on the outside of parentheses, you have to distribute that. You multiply everything inside of it. So you end up with N2, H is hydrogen, 8, and sulfur 1. All right, guys, that takes us to the end of that section. I'm Mr. Hescox. Make sure you get your work done. Be good, be safe. I'll catch you next time.